everyone, welcome to this video, and in this video we're going to discuss some basic ideas about set through some exercises that I have prepared that I copied from a book which is E-Math by Set. So let's have this one. So identify the sets are well defined or not. Remember that the set should be well defined. So let's see this one. So number one, the set of factors of 18, is it well defined or not? So technically, when you say factors of 18, okay, let me just change the color of my pen so that it would have an emphasis. So factors of 18, technically when you discuss that, 18 has different factors such as 1, 2, 3, 6, and then 9, and then 18. So these are the factors of 18. So technically, this is a well-defined set. Okay. Now, let's go number 2. The set of friendly students. So technically, it's a very good to know that there are friendly students in a class. However, when you look at now the word friendly, it turns out to be a standard that could be subjective or it could be different from each other. So this is not well defined. Okay, another thing. Now, the set of senior citizen. Now, senior citizen has a standard legality when the age of a person is 60 and above. So therefore, it is a well-defined set. Okay, now, going back now, let's go now to another idea. So we're done with the definition of set. Now, let's go now with the idea of subsets. Now, let's answer a problem now. Let's look at now this one using set 1, 2, 3. 1, 2, 7 rather. So the first question is to identify the subset. Now, when you have that, we know that the cardinality of set is 3, right? Cardinality, oops, let me erase that. Oops. The cardinality is 3. Okay, now, we can now define this in 4 sections. So, we have now 0 at a time, 1 at a time, then we have 2 at a time, so 2 elements at a time, and the last one, which is the maximum number, is 3 at a time. Now, when we say 0 at a time, one of its subset, and remember that the subset of any set is what we call the null set. So we have 1. Now, working with that 1 at a time, we can have every elements in the set of 1 to 7. So we have now set containing 1, set containing 2, set containing 7, and there are 3. Now, when it comes to 2 at a time, we pair that, but it should be distinct. So the first one is 1, 2. Another is 1, 7. And the other one is 2, 7. And lastly, 3 at a time, we can now put all the elements, which is 1, 2, and 7. Now, if you were going to be asked how many possible subsets, you can work that out if you count 1. So if we're counting that, we have 1, 2, 3, 4, 5, 6, 7, 8. However, there is an easy way on how to get the number of subset. Now, the base number is 2 and then n, which means n is the cardinality of the set. Now, using now the problem, we have we have a set which is 1, 2, 7, and we know that the cardinality is 3. We could solve that as this manner. So we have now 2 raised to 3, which means 2 times 2 times 2 when we expand. So answering that, 2 times 2 is 4 times 2, and that is 8, which is the same with our answer when we count it. So the formula for getting the possible number of subset is 2 raised to n. Okay, now let's continue. Let's have here this problem when it comes to equal and equivalent set. When you talk about equal and equivalent set, let's talk about equivalent. We have now same cardinality. And when we talk about equal, we have now same cardinality and elements. So, if the elements are the same and the cardinality is the same, cardinality are the same, we call it equal. When it comes to equivalent, it will have same cardinality. Now, when we talk about equivalent, the symbol is like that, and then in some other book, it's like this one curly. But for equal is this one, the straight one. Now, let's go on number 1. Number 1, we have now the set PET. And then TEP. As you can see, you can now analyze what's the cardinality of this set. The cardinality is 3. The cardinality is 3. Therefore, it is equivalent. However, as you can see, they are the same. P is there, E is there, T is there. Therefore, we could say that this is equal. So, automatically, if it is equal, it's already equivalent. Okay? Now, let's go on the next one. So, we have now set starting with 2, 4, 6, continuing until 20. So, those are even numbers from 2 to 20. So, when you talk about its cardinality, the cardinality is 10. Okay. Another is 1, 3, 5, continuing to 19. And I believe the cardinality as well is 10. However, what we can conclude there is that 2, 4, 6 going to 20 is equivalent to 1 set that contains 1, 3, 5 until 19. Because they are just the same number of elements. However, the elements are not the same. Okay. Now, let's go with number 3. This is some kind of interesting. These are names. So, first one is Jose, Apolinario, and Andres. So, we have Jose, Apolinario, and Andres. So, as you can see, the cardinality is 3. And then the last, on the second set that we have there for item number 3 is Rizal, Mabini, and Bonifacio. Now, as you can see, the cardinality is 3. However, even in context, we could say that Jose Rizal is the name, Apolinario, Mabini, they are just the same. However, there could be other Jose, like Jose Laurel, Apolinario Santos, Andres Mula. So I think now we can say that these two are equivalent set. I hope you learned something with this video about some basic ideas with set. Thank you for watching this video and have a great day.